Hello folks, we come to the part 5 video of this exercise 5.3 and there are just 2 problems left, so let's get across directly. Now the feature of this video is that, or this part is that, all this time we were doing the substitution x as tan theta. So it means you would be thinking that yes, x equal to tan theta generally works in all the cases. Doesn't happen like that. You have to look at the function, you have to look at the formula that can be related to this, and then you go in for a substitution. It's basically the formula. If you know the trigonometric formula well, you know what is the substitution that's going to help you. So it's on the basis of that we are going to make the substitution. So in both the cases we are not using x equal to tan theta, we are doing other substitutions so that we are able to get the answer. Now here, if you carefully see, it is sine inverse of 2 into x into root of 1 minus x squared. So logically it is very clear to us that you should get sine something here, or you should get cos something at the most, otherwise this is not going to help you. So you should get sine and cos. Cos is 2 theta or whatever. If you see the formulae, they are not so accessible in this form, but at the same time we know that sine 2 theta is 2 sine theta cos theta. So if we were able to get x as sine theta, then probably we could convert this as sine 2 theta and work. Understood? So that prompts us to use x as sine theta. So let's make that substitution. Let x be sine theta. Automatically theta becomes sine inverse of x. Now here one more thing, we'll see what is x squared. It is sine squared theta. So what is 1 minus x squared? It is 1 minus sine squared theta. We all know it is cos squared theta by identity. So what is root of 1 minus x squared? It is going to be root of cos squared theta, which is cos theta. So that helps your y very much. Therefore y now becomes sine inverse of 2 sine theta and cos theta. We found out, right? So that is by formula we all know that it is sine 2 theta. They do fall in the domain that is given in the problem. As a result, sine inverse and sine, they are identity functions, and as a result they become identity function on composing. So you are left with 2 theta, which is 2 sine inverse of x. Now we plan to take the derivative on both sides. Dy by dx is 2 times derivative of sine inverse of x. We know it. Derivative of sine inverse of x is root of 1 minus x squared. So this comes to 2 by, that is our dy by dx. For the first time we are using a substitution which is not tan theta. Sometimes children feel, tan theta. No, it's not tan theta. It is a formula that is going to help you to make the substitution. Same way here now, y is sec inverse of something. That means you should maximum get this as sec or cosec, not more than that. You should get sec or cosec as an cosec when you have the overall function. So because you have 2x squared minus 1, we have to relate it to a formula which is of that kind. And if you see, you will have cos 2 theta as 2 cos squared theta minus 1. So the substitution that is going to work here is cos 2 theta. So let's see how it is going to work. Let x, cos 2 theta, cos theta. So let's see how it works. Let x be cos theta. So like that, theta becomes cos inverse of x. Now, if you want, we can do this simplification here. X squared is cos squared theta. 2x squared minus 1 is 2 cos squared theta minus 1, which by formula is cos 2 theta. Yeah. So what happens to y now? Y becomes sec inverse of 1 by cos 2 theta. 1 by cos 2 theta we all know is sec 2 theta. And this 2 theta now, it is very much in the domain that is specified in the problem. As a result, sec inverse of sec in composition form becomes identity function, and as a result we are left with 2 theta. So y is 2 theta, which is 2 cos inverse of x. We take the derivatives. Dy by dx is 2 times cos inverse of x, which is 1 by root of minus 1 by root of 1 minus x squared, or rather minus 2 by root of 1 minus x squared. So that's all about this part, where we had only these 2 problems left in the exercise, and that's how we are done with the exercise 5.3. The next video will come with the new exercise. Thank you.